This is my second OAI workshop because, of course, when Ericsson joined OAI 2 years ago, it coincided with an OAI workshop in Eurocom, and I really enjoyed that. So when the opportunity came to host it here, of course, we were very optimistic about it, thanks to Jimmy and others. So my brief talk this morning will be on the topic of what we call system comprehension, and this is basically motivated by the sentiment we have that most of the AI technology that OpenAI, Anthropic, and Google bring out is basically just cool tech demos. I mean, that technology advances in terms of reasoning and capabilities, but as it advances into more advanced reasoning, it becomes less and less useful to industry. And so I'll make that case, and I'll see if you agree with me on that basic premise, and then I'll sort of try to kind of dig into the topic of what's the big problem in our industry, and what is the sort of fundamental thing we need to get right so we can actually get the chance to build 6G, and if we get the chance to build 6G how do we do it the right way? So I'll introduce myself first by introducing the team I lead. We have a team here in Radio Networks R&D called AI and Emerging Technologies, responsible for embedded AI in RAN layer 1, layer 2, layer 3. This is all of the things you know, embedded systems engineering, AI in RAN. The team is responsible for generative AI, which has ramped up substantially over the last sort of a few years. And the team is also responsible for network analytics. So we collect data from sort of 140 or so live networks. Most of Ericsson customers choose to stream all of their network telemetry to us, and we sort of terminate, what is it, maybe 10 or so terabytes a day of incoming data streams from the world in something called radio data insights that operators then use for benchmarking and other things. And then the thing that you know me from before in the OAI context is software technology, digital twins, network simulation, and a lot of the work we do with NVIDIA and others is also in the remit of the team. So it's kind of, since you met me before, it's been growing a little bit in those AI areas. So let's make this the normal marketing opening. I mean, half of the world's 5G traffic outside of China flows through Ericsson products, and this is something that when I saw this number, I just felt, well, that can't be true. But it turns out that it's true, and it really motivates sort of, us to come to the office and think about sort of, okay, can we do AI at scale? Can we do AI at this scale? And it also sort of underlines that the systems that carry this traffic are insanely complicated. I mean, they are much more complicated than I will ever digest in my career at Ericsson. I mean, I think I'm maybe at 5% understanding of the RAN system we build, 5 or 10%. I mean, I know a little bit of the physical layer, a little bit of the control plane maybe, but you can't be in any of the big telco companies and understand the whole product. That is impossible. It's why we stay here, right? Because we're always learning. But it's also, a pretty scary thing, because of course, if nobody understands the whole thing, how are we gonna evolve it? Yes. But what if this is then really fundamentally true? What if we are comprehension bound in networks? Now I'm speaking of from an Ericsson standpoint here. I mean, with the complexity we have, with the scale we have, with the amount of features in RAN we have, with the deployments we have, what if we are comprehension bound? And you might understand this as kind of in distinction to being bound in the traditional sort of 3 dimensions of project management. Either you don't have enough money, or you don't have enough people, or your scope is wrong. Right? I mean, those are the 3 variables we typically play with if we're executing on a project. But what we're positing here, without making it sound like we're a bad R&D organization, we're sort of positing that maybe it's not these 3 topics. Maybe it's not people. Maybe it's not money. Maybe it's not scope. Maybe it's actually comprehension. right? Maybe it's if we want to evolve this product we have and the industry we're part of, we face a lot. We face, again, speaking from an Ericsson standpoint, diminishing returns in putting more money into R&D, right? Because more people into these teams, incrementally become less productive. And so, I mean, it's sort of the narrative we use for AI then. Sort of, okay, if we are comprehension bound, what does this mean then for us, right? It's also maybe how we think about what we can do as an industry or as players in this industry to make it possible to evolve into 6G. I'm sure you all sort of broadly understand that 5G is a tremendous success for some players in this industry. I mean, Nokia and Ericsson and so on are making a lot of money on 5G, but it's not what we said it would be. I mean, most of us in this room, or at least half of us in this room, were part of describing 5G use cases back 10 years ago that were about remote surgery and autonomous driving and all of these things. And you can think about why didn't that happen? And it might actually be because we took on too much complexity. It might not actually be anybody's fault. It's just that the weight of complexity of the use cases and the variations of configuration and so on that we talked about, maybe that doesn't add up. So so then we started thinking about sort of, okay, what then is our role here? I mean, if this is the problem, then clearly AI is part of the solution. But what is our role? So then you can sort of take a more scary, from an Ericsson standpoint, a more scary question here if we're focusing back on AI. I mean, our customers are also customers of the big hyperscalers. Like AT&T is a big customer of Azure. I mean, Verizon is a big customer of Amazon Web Services. SoftBank and SKT and so on are big customers of hyperscalers. And what happens when our customers, Ericsson's customers, takes all of the data from all the network functions and sort of feeds them into the hyperscalers and the OpenAI and the frontier model labs there. Is that good for Ericsson or is that scary for Ericsson? It's certainly something we worry about, right? And it's not to say we need to be better than OpenAI at AI. That's not what we mean. But it says there's a position in the industry we don't want to have. Like, we don't want to be the data source for somebody else's AI that understands the network. So if we are comprehension bound, and the solution is to sort of do large scale AI to manage networks, we don't want to be just a data source, right? So. So I'll speak to. I mean, I'll give you. I'm giving you sort of a little bit of a background and a detour about sort of why we've been creating sort of an AI lab in this company and what it's about. So what we then did was we created a group called the System Comprehension Lab. This is about a year and a half ago. I mean, a year ago. Claes, you're a founding member of the lab. We can say. It's clearly about internal alignment. I mean, there are thousands of AI use cases sprouting from within the sort of 35 or whatever it is, 1,000 people in Ericsson R&D. And what's the common goal on all of that? What's the core capability? That's a question of internal alignment. We know that we need to get good at Gen AI in our product, right? We know that in the 6G context, we will have to use kind of transformer and attention-based methods and generative methods in things like the control plane, in RRC, maybe even in the scheduler. Maybe that's the paradigm we need to master. But if you look at those technology areas, they don't justify the investment to get good at generative AI. I mean, because you sort of see this pile of this requirement of investment to get good at generative AI you don't address that by, you don't justify that spend by looking at the RAN use cases themselves. So we said, okay, let's look at the bigger question of system comprehension and invest in that question. And based on that, we get sort of some sort of opportunity to work on in the future work on 6G related use cases in this space. So what then I opened with was the benchmarks you see from OpenAI and from Anthropic and other things. I mean, these are really cool things. I mean, they can do competitive math, they can do competitive programming, they can do all of these things, and those are incredibly important and awesome, AI progress in general tasks. And I mean, if a year ago we were maybe asking, is there some real intelligence in AI? Maybe the advances in reasoning makes us think that there is actually real intelligence. But what becomes obvious when you start to apply these tools to sort of an R&D space is that they're useless. I mean, and in fact they're getting less useful. I mean, the gap between what they can do in tech demos like coding and PhD level science questions, the gap there to useful things in a systems engineering organization, that gap is widening, meaning that the things that they're bringing to market have no utility. I'm not going to say they have, okay, maybe no utility is slightly too strong, but basically they have no utility because they don't understand anything at all about the environment where we build our products, right? So, so for example, if we're to leverage AI to kind of transform R&D in Ericsson or even take our products to market, the AI systems have to be grounded in our technology, our processes, our code, our cultures and values, how we do things. I mean, there's a question of reasoning in AI, which is to say, can you reason around 3GPP? Can you reason around how a GNOD works? There are 100 million ways to reason about it. Now, if you can reason about how an Ericsson GNOD works, it's a totally different thing. I mean, of course, the frontier model labs can learn from Wikipedia and from 3GPP and from other things, the general sort of reasoning space of how a GNOD works and how it's designed and how we think about, the research question. But to take the leap to sort of how it actually works in a system that you build and that you ship and that you maintain and that you sort of handle over the life cycle is a completely different thing. And the gap between these two things has been widening. So we don't see any of the sort of big AI firms really caring about this in a lot of ways, right? So then this is not an Ericsson question. I mean, I think if you ask Airbus, is AI useful for building an airplane? I think you'd get the same answer. If you ask, Thales, if you're going to use AI to build satellites, I mean, you're going to get the same answer as I'm giving you here, that sort of, if you're a big systems engineering company, if you're building big complex systems, you actually have still to do the work rather than, so just kind of buy some AI tools from the street. Which then is the question of sort of, okay, what is then a reasonable level of ambition? I mean, you can say one can try to have the ambition to be a frontier model lab. Like if what I say is true, and we sort of need to be within telco, within for us and for our customers and for you guys, maybe we need a frontier model lab. I mean, that's the maximal ambition. But it's of course a multi-billion-dollar effort, and it's huge legal risk, and it's all the stuff that Ericsson cannot take on, and I think most European companies can in fact not take on anything even approaching sort of a frontier model lab kind of technology. I mean, then we could of course ignore Gen AI and say we'll be fine anyway. I think that's a really, really bad idea for all companies and for all communities and all ecosystems. We can take all of our code and all of our documents, and we can kind of ship them over to Microsoft and have a co-pilot ingest them, and we can take all of our technical specifications and all the things and just send them over to Microsoft and hope for the best. And maybe there's a good strategy. I mean, it's not a completely foolish. I mean, It's quite a foolish strategy, but it might turn out well if you're lucky. It's not our strategy. Then you can try to do the same thing with as the SaaS players do, but you do it on-prem. So you buy your own GPUs, you buy your own tools like Codium and others. But if you play this game, you might get some tools that you can use, but you don't build up that strategic competence. You don't infuse AI into our ecosystem. You don't infuse AI into our companies. You're still just using somebody else's tools. You're on the roadmap, so to speak. You could maybe on the more ambitious side again think about, can we build a small model like Mistral or Databricks or whatever? It's still a very large investment, and it's a very, very big legal risk. Again, it's probably not something that most European companies would be comfortable doing, scraping the web, especially not for domain-specific knowledge like we have. And of course, there are pure academic efforts where we like to play. I mean, if you're in the pure academic space, there's a lot of subsidized compute. I mean, somebody else is buying GPUs, and that's pretty good. I mean, we do want to use the free GPUs that are out there, but of course, the issue is if there's any corporate data there, it's a very challenging strategy to execute because of secrecy, and you're basically obliged to publish, which we're not against doing, but not for all the things. So the comprehension lab is then sort of the middle ground here between having no agency as a company or as an industry, and having autonomy, which we would like to have autonomy. We'd like to have all of this destiny in our own hands, but it's unfeasible. Like we can't do this. But if we try to say, okay, let's get really, really good at customization, let's get really good at systemizing solutions, let's get really good at leveraging the hyperscalers, let's get really good at our in-house data efforts and be sort of first followers. In this setting, there is at least agency, right? We can do the work. We're not autonomous, we can't do it independently of the hyperscalers, but we're at least doing the work. So that's how we think about the strategy. Now, to get a little bit technical about this before you get bored here, so there are sort of things then that goes into this question of system comprehension. What does it actually mean? I mean, from an internal standpoint, it of course means taking all of the documents and all of the special things that like makes an Ericsson R&D environment what it is, and getting AI to sort of understand that. And from a customer standpoint, it's about being able to ingest all of those configurations, all of those deployments, all of that data that streams from the customers, and sort of say, okay, that's the customer view of system comprehension. So if we look at, I mean, maybe we'll take a specific example. I mean, Ericsson makes its own ASIC. We make custom silicon. And so since we make custom silicon, there's no code model out there that can generate code that we can put in an Ericsson RBS. So that's clear, right? I mean, we have a base model. I mean, you're not allowed to tell anybody here, but we have a base model from China that we think is absolutely great. From DeepSeek, you heard DeepSeek made some news in early this year and caused NVIDIA's stock price to crash. Of course, NVIDIA is back recovered, so no issues there. But we use DeepSeek as a base model, and then we customize it by showing it all of our source code, right? Because again, this base model has never seen signal processing code running on custom silicon for Ericsson. So we have to train the model to do that. So it's all of our PHY, it's all of our MAC, it's all of our ORM code, but it's also system documents and product documents that goes into kind of training the LLM to actually understand, not any signal processing implementation, but specifically the one we care about. So this is the process of learning by observing all data. And then, of course, you have to learn by observing curated examples. So you have to learn by giving good examples and bad examples, and patterns and anti-patterns, and this is called instruct training. And then after this, there's a phase of reinforcement learning with human feedback. So if just to go through a little bit of the lessons learned here, I mean, to make an LLM, you start with pre-training, and this is what, in our case, then this is what DeepSeek does. And this effort is very, very high on compute, and it's sort of medium in human time. So human investment is not enormous here, because you have, I mean, it's not nothing. You have to actually do the work of collecting a data set. So this is not what we do. We go in here and we do continued pre-training. And compared to pre-training, the continued pre-training is much, much cheaper from a compute standpoint, and it's also much cheaper from a human input standpoint, because we're adding only the secret source. I mean, we're only adding our stuff. We're not collecting data from the internet, and we're not, we are changing all the model weights, but we're not training it from scratch. So it's substantially cheaper. Now, instruct training then is much, in our experience, very much dominated by the human effort, because the instruct training is expert written examples, what's good code, what's bad code, what's correct, what's incorrect, all of these examples where the model mixes up NR and LTE, the concepts in the control plane have the same name, but they work differently. All of this stuff has to be handled by human written examples. And these are not human written examples you can outsource to countries far away. These are the best of the best experts being asked to write these good and bad examples. And you have to write many, many thousands. And then comes reinforcement learning with human feedback, which is actually quite taxing compute-wise. It's the heaviest workload for us, because you change the weights of the model based on in this reinforcement loop, and it's also the biggest workload for us in terms of the human effort, right? Because again, we put these models out there to use by some experts, and they say that's good, that's not good. I mean, we cycle through that. So this just gives you a sense of sort of the life cycle of the LLM training phase. So looking at this, I mean, maybe you don't. Maybe you're not so into sort of the IT related stuff here, but there's no chance Ericsson can build the infrastructure to do this on ourselves. So we run all of these things in Amazon Web Services. There are, I mean, we put in the source code and the system documentations and so on, and that goes into data prep, and then into the different training pipelines, continued pre-training, instruct training, and RLHF. Clip model is something different, but then we just hand the models over to Amazon to serve them. So this is one part of, I mean, this is one part, if I go back, this is one part of the sort of overall technology stack, right? I mean, we need to be able to train custom models, and then the other part is we need to stitch them together with retrieval augmented generation and agency. And maybe I'll go through that more in a demo setting, because I promised Florian to not run over time here. But so just the basic code model here, of course, can do what you ask. I mean, if you ask it to make a fear filter in the style that we would recognize as Ericsson code, I mean, Laurent and others, you will recognize some fancy keywords here that denotes storage class specifiers that are different than what you find in normal code. So, I mean, what the model accomplishes here is to actually make an implementation of some functionality in the constraint of the custom silicon, right? Which is, again, not the whole system comprehension challenge. It's just a proof point that we sort of can tame these models and make them useful for us. So together with Amazon Web Services, we proposed this demo to Mobile World Congress in March, and this one is different. This one takes more of a system comprehension angle to it. Like, we start with thousands and thousands of documents that describe how our LTE system works, and you sort of want to have you want to ask questions about an LTE feature, not LTE in general, but an Ericsson implementation of the feature. Then you want to go from that thing that you're asking for to where is it in the code. So you want to do natural language search in the code, and then you want to take the code that you found and you want to feed it into our custom ASIC LLM and have it explained back. Right? So we don't use the custom silicon LLM to generate code as much as we do to explain code. And so this is maybe, I mean, this is not the full comprehension challenge, but certainly it starts by explaining, I mean, asking a question and sort of spending time in retrieval and you know, asking both the broad question about what is HARC and then specifically how is it implemented in our systemization. And I'm not gonna you know, bore you with all of the details here. I mean, I think we might even speed this up a little bit in terms of you know, examples, but then we're going into this contrastive learning model to search for this concept in the code. So this is natural language search over the code base, and you know, as we jump into some piece of code here, we'll just ask the model to sort of, I mean, explain what this piece of code is doing. So you can imagine for a slightly more junior team to be able to kind of query the tens of thousands of documents we have, both 3GPP and you know, all the open documents, but also the closed documents, get to the code where this is implemented, and sort of from that code have the code explained back to them is something that we think sort of changes how we might do systems engineering. This is not human replacement, right? But this is still sort of making all of this technology that we read about, making it actually useful. So from documents to the code and have the code explained back. I mean, that is one of our core challenges. I'll take a more complicated example. I'm not going to explain how this all works, but the multi-agent retrieval augmented generation works by is what we do with in the area of system documentation and systemization. So this is recognizing that we have all of these documents that have structure, we have the documents that have no structure, and an agent has to query and sort of use different tools to sort of get to different pieces of information. And if you start to ask a question like, let's put in a question here about explain how a UE is connected to the network from power up until the user is able to transfer data or make a call, and we'd like to know the system classes and use cases involved. So this is not a question of, again, from a 3GPP standpoint, this is a question from an Ericsson standpoint. And the model will just, I mean, now we're giving you the unfiltered view here, but it's basically, it will search for about 10 minutes. The AI takes about 10 minutes to give you the answer here. And it will give you a stunning amount of output. And so it starts with the broad search. So it broadly sort of tries to understand, okay, what is this question about, RRC connectivity, and then it will go into sub-tools that find more and more specific information about this. And it goes into our system model where it's finding, you know, the different things. And I mean, to uncover all of this stuff would take a long time. Right? I mean, to go through this, you know, as a person, and just kind of, if I didn't know RRC and if didn't have working knowledge here, I mean, so you get to an answer which is, you know, a couple of pages long, which is quite concise, and it deals with the things that, you know, somebody who knows 3GPP would sort of broadly understand. But it also then goes into all the specifics of how Ericsson has systemized this. what are the system classes and key use cases, and I mean these are the things that we care about then. And this is where it starts to get. This is where we can say this is really useful AI. This is expert grade, and the stuff that maybe takes a week, and now it only took a couple of minutes. And I mean, I mentioned this because I think we need this, right? I think we need this as an industry. Yeah, I mean, okay, obviously you can get this rendered in a nice flow chart as well. I mean, obviously the AI can do that. But I'll just close by saying if we don't manage to master the complexity in the networks in deployment, it does not really matter much, because that is the thing that is holding the entire industry back. 5G didn't really become what we wanted it to be, in my opinion. We're challenged on whether we're allowed to make 6G or not. And I think the way to sort of prove that we can make 6G is that we can manage the complexity of what we already built. And it starts by being honest about the fact that that complexity is actually a big deal. Now, that also serves as a foundation to ask, okay, what's the role of AI in telco? And mastering that complexity will make our business better, it will make it more enjoyable to work in these big companies, and it will make, it give us the opportunity to innovate in the future. So that's why I wanted to share this story and share about how we're tackling the big picture about complexity. Thank you.
Right. Thank you, Doug. Thanks for this presentation, and thanks for sharing all those Ericsson trade secrets with us.
I mean, I'm intensely comfortable with stuff like this.
We should do the same thing with OpenAirInterface. Then we can make a public
exactly
AI chatbot.
I mean,
query OpenAir.
And if you can say, OpenAir is a comprehensible system. It's a system that somebody can understand. Mm-hmm. It's actually a pretty big point. Yeah, because it means that then you can build, and then you can evolve it, and you can change it. Yeah. So,
any questions to Doug? Yes.
One question here.
Hi. Thank you for the presentation. I was surprised to see that you were Is this just one utilization of the AI? Or do you have multiple? Is this demo just one?
Yeah.
I was surprised to see that it's on the code.
Yeah.
I would have expected like logs, configurations,
yeah.
the quest for easy, right?
Yeah, no, we can.
Would have expected it there.
Yeah, you can. I mean, normally these talks are about 4 hours when we explain the comprehension lab. I mean, and when we have demos in the team, they're typically a full day. So yeah, I had to leave some things out. There are use cases like this, but if you ask, okay, what's the most fundamental challenge we have? I mean, okay, the logs come in and they have to be interpreted. That's exactly the same problem as having system documentation and having systemization and explaining that to a developer from the other direction. So if you solve one problem, you sort of automatically solve the other problem, and so they're basically one. But you're right, that would have been, from an operation standpoint, the most important one on that side.
And there was another question here, yes?
Yeah, so this is very, very interesting and, kind of eye-opening, that because the whole problem of doing this, the RAN, developing it and testing it, debugging it. So what about test and debug? Do you also have some kind of AI? Are you experimenting with that? And also static analysis of code. Do you have some kind of code analysis, specifically in RAN?
Yeah, so, I mean, let's be... I didn't speak to this picture, right? But static analysis is one of the data sources if you're trying to understand how a piece of code works. Static analysis is one of the sort of specific structured ways you can feed data in here. Now, that's not the only thing, because, of course, when an LLM interprets code, it's a form of... it's not static analysis, but it's a complementary analysis that the LLM does when it interprets code. So, this is vastly complicated, and I'd say we have no shortage of use cases. What we do focus on is working on a few use cases that are really fundamental, and then scaling it, that way. So the static analysis use case, and we have experiments on that, but it's not the main focus. We will get there, I hope.
And testing and debug?
Yeah, well, I mean, again, it's part of the broader agenda, you know.
All right, I think in the interest of time, we have to stop here. Sorry about that. Let's thank Doug again. All right. And yeah, let's move on. Thank you, Doug. Let's move on to our next speaker.
Thank you.
Well known to Eurocom and people in Sofia Antipolis, Issam Tufik. He's now CTO of Etsy, where they host a lot of 3GPP workshops, and he's also deeply involved in 3GPP, and he's going to talk about exactly that, insights in 6G standardization. Issam.
Thank you very much, Florian. And just to let you know, I went for dinner yesterday and we survived. We have not been shot, so the workshop is a success for those who were here in the opening session yesterday. To build this presentation, actually, I looked at the title of the workshop, and there were several keywords. There were 6G, EI, OAI, so OpenRAN. So I tried actually to cover all these in 3 separate points, so maybe a little bit disconnected, but they all from a 3GPP perspective point of view. So I will start first by what 3GPP is doing on EI/ML. Just to state first that EI/ML is already existing in the telco industry, but both in the network and the device has been for a while, but as an implementation choice. There was no standardization work so far until release 17, where 3GPP started looking at how to put some framework around EI and ML. And the aim of 3GPP looking at this is to improve the network performance, both network and device, while recognizing the existence of such methods already in the industry, and also provide operators with some governance on how to manage and control the capabilities of EI. 3GPP will not standardize the models, so models are, as we saw, remain the secret sauce of each operator, each vendor. But what 3GPP focuses on is as I mentioned, some governance around the monitoring and the control of the models, mechanisms for that. So the activation, switching of the models, but also providing additional or extensions to the air interface and measurements, so to support the EI/ML for training and inference. And also, finally, putting some based methods or standard-based methods around training, data collection, and then the transfer of the models and their delivery. When it comes to the training, 3GPP so far is dealing only with offline training, so which means that when the model are commercially deployed, they have been fully trained and tested. So online training is out of scope for the time being. But if in the future with computational advancements, that may be considered, and there are some thought that may be on the scope of 6G. This a little bit answers to some of the questions that were asked yesterday. Where is it good to use EI? Where is it not as such relevant to use EI? EI is a good tool when you are dealing with data analytics, especially when you have multiple sources of data. And network optimization is a prime example of where EI can be used. It is also great for solving complex problems where you don't have an analytic solution. However, if you have a mathematical solution, don't bother with EI. You already, I mean, you don't, and that goes to another one concern I mentioned later is the avoiding the use of EI everywhere. With the hype, we are trying to use EI in all sources everywhere, but there are problems where EI is relevant, others where it is much less. And finally, the last point is context awareness or data-driven predictions. These are again good examples for AI. But we do have also some concerns, and one of them is how to test. 3GPP prizes itself by having a predictable behavior of especially the device side. Whatever the vendor you take your EU from, you expect that it will comply with a certain minimum requirement. With EI, this becomes a little bit complicated. So testability and device behavior consistency is one of the challenges. Feasibility of one type of the models, which we call two-side models. I will come back to that to explain first what is the two-side model, and all the controversy and debates around data ownership and data sharing. Data becomes money because no one wants to share their data. And I think the operators here learned their lesson, so the network is used as a data pipe, but they are now we are building mechanisms around how actually the data can be monetized as well. Looking at the work that is ongoing or has been going in 3GPP, while we started talking really about EIML around release 17, 18, there was already some blocks that have been adopted in earlier releases that shows to be enablers for the EIML. First, the SA groups. For those who are not very familiar with 3GPP, SA groups are the ones who are dealing with the system architecture and services, and SA2 is the architecture group. They introduced in release 15 the network data analytics function, which initially was intended for the network slicing analysis, but now is one of the enablers of network automation and EI. In SA5, which is the group of OAM, they also introduced this function, which is the management data analytics. In the air interface and the RAN side, there was also in early releases some work done on the data collection for self-organizing networks and minimization of driving tests. And RAN 3 started the release 17, a study on how to use EIML for the RAN. And they developed a functional framework. I'll come back to that in a later slide. And also, I will move faster because these are covered in more detail in the following slides on how to use EIML for the air interface. So first of all, as I mentioned in RAN 2, RAN 3, there has been intensive work looking at the application of EI for the radio air interface, and we established a framework for that and a model for the life cycle management. So we have here the diagram that has covered the whole cycle of EIML, from the data collection to the training, management and storage, and finally the model inference. And we are considering two types of models here: the functionality based, where the network is the one responsible for activating, deactivating, and switching of the models via signaling, and the second one is where the models have unique IDs, and can be both the network or the EU who is doing the selection and operations. I mentioned earlier some challenges with the two-side models, but what are these? So in 3GPP we are considering both what we call one-side models, and this could be EU-sided or network-sided, and it speaks to where the intelligence is, where the EI is sitting. So it could be either in the EU or in the network. And then we have the two-sided model, where it's a shared model. We have one part in the EU and the other part in the network. And it is challenging because how do you ensure the interoperability when multi-vendor interoperability when the models is sitting two parts in different sides of the network, and also joint training becomes a challenge. And we have in release 18 have been considering different use cases that 3GPP has been looking at, and some of these have been already covered to some extent yesterday. First use case is for the channel state information, and this is the one among all these who is actually using the two-sided model. And for the release 18, the focus has been mainly on the time domain prediction. The second use case is the beam management, both spatial and temporal downlink beam prediction, where the model inference can be either at the G node B or the EU. So both of the models that mentioned, EU-sided or network-sided, can be used here. And the third use case, which is positioning. And here again, we have two types of models where we are considering. The first one, which is the direct AIML positioning, where the model gives you the exact position, and the second one, where AIML is used to assist the decision by generating intermediate statistics. And finally, and this is more a study which is ongoing in release 19, is how to use EAML for predicting when to start the procedure for handovers, etc., for mobility. On the data collection, this is an ongoing work between RAN2, SA2, and SA5. And the 3GPP is looking at 3 different cases for the data collection. The first one is where the data collection is over the top. And this is already something which is happening. So again, this is there is no involvement of the network. This is outside of the operator, and this is using proprietary solutions. So what 3GPP is doing is like, okay, let's now involve the network, and what we are looking at is when the data collection is at the core, and it is transferred for externally for the training, and the other one is where the data collection resides at the RAN, on the OIM to be precise, and again, transferred externally for the training. For the, as I mentioned, we are looking also at the model transfer and delivery, and here we have also several options for where the repository is located. First one, again, is existing proprietary, where the repository is over the top, is outside of the operator's network. And then 3 cases that where we look at the where the repository is located, and the difference is on the location of that repository, but also on the what mechanism is used for the model delivery. So if we take the example for the third one, for example, where the repository is at the RAN, and we are using the RRC or user plane, so the choice between one or the other for the delivery of the model. While we are looking, for example, for the second one, this resides at the operator, and we use the NAS signaling for the model delivery. I mentioned the work in RAN, so now we are moving from the air interface to the NG RAN. It's already started in release 17, where RAN 3 has been looking at how to use the AML optimizing the RAN, and they developed this framework for the RAN intelligence, again covering the data collection, the training, and model. And what they looked at exactly when we started the normative work are these 3 use cases. First, on the mobility optimization, energy saving, and load balancing. And as we are now in release 19, we extended this, so the way 3GPP working is really to look at very specific use cases and how to handle these. So we are extending to network slicing, mobility optimization, split architecture, etc. Finally, I mentioned the problematic with testing EI, and RAN4 is the group tackling this problematic and looking at developing the requirements for the tests and procedures. That covers the life cycle management, the data generation, and the verification for generalization. Now moving a little bit to the second subject, which is, okay, this, if you have noticed, release 17, 18, 19, they are all 5G. So now we are moving a little bit to the future and looking how is 3GPP looking at the upcoming work on 6G. And for that, we had a workshop that took place in Incheon 2 months ago. And this is exactly actually the output summary of that workshop. I will go a little bit fast on these because of the sake of time and because a lot of this has already been covered in many of the presentations. And first of all is why do we want 6G? And I do agree with, I don't remember who was the speaker yesterday who said we are now seeing a little bit less focus on the performance and we are having a, I would say, more focus or more attention to the business side of it. How do we operators make money? How do we reduce the cost? And we actually spell it very clearly here is revenue growth and monetization. That becomes one of the key drivers for 6G. But we are also talking about things like the cost of ownership, how to reduce the OPEX and CAPEX, simplify network so that the operational side becomes more efficient. And of course, we have, as always, the user experience is at the center of it. We develop a new generation, is to bring new services, is to provide a better experience, and that includes the coverage, of course. The goals, so taking it a step further, what we are trying really to have as our aim when developing 6G is sustainability. It's been in the agenda for a while. It's been already the case for 5G, but not from day one. But now we are talking about sustainability as an aim or a goal for 6G from the start, and designing 6G with having this in mind. Resilience and security, these are also becoming, especially with the context that we are living in today, become really a must for the mobile communication systems. The three on the side, these are not new. This is something that comes every generation, of course, customer experience, efficiency, and the core of any standard, which is interoperability. I will actually come to that specific part, which is the interoperability, because one key message here is we want to avoid fragmentation. And fragmentation is both in the technology, but also on avoiding to have regional standards. In order to develop 6G, let's look back at what we did wrong. And I do agree with Dag that we were not so successful. It depends whom you ask. Some made money out of it, but if you ask the operators, and especially in Europe and US, they were not so satisfied with how the whole 5G journey went. And we tried to look at what made it so, what went wrong. And some of the lessons is the complexity. We have made so many options in the standard. Sometimes even for the same feature, you would have a multitude of options. So this is one of the problems that made the deployment of 5G complex. The second one is the migration challenge. Here we started with, because we wanted to bring 5G to the market as quickly as possible. So we had this standalone, non-standalone approach, which with time proved to be not the right approach. The fact of having non-standalone delayed considerably the development of the standalone. And if you want the full potential of 5G, you need the standalone. And then there are to the right side again some more technical, I would say, issues that we have to tackle with 6G. So deployment inefficiencies, and here we talk about the network repository function, which is the register for all the network functions, which seems to be quite complicated and face some challenges. So these are, in my opinion, one of the key issues that we are trying to tackle with 6G, or do differently with 6G. And this is what basically it says here. So for 6G, what we will try to do is focus and be simple. So adopting a lean and streamlined standard for 6G, avoid the multitude of options. Other things that came out of the workshop is we want 6G to be cloud native and AI native. What native means, so there are multiple definitions of what it really means. One definition is that from day one, it has to be supporting cloud and has to be supporting AI. Another one is this plus for everything we are developing, we have to keep in mind that we have AI, we have cloud, and so that's the way we are developing our standards that will be influenced by this assumptions. Software-driven deployments, though this is that the operators are very keen on as well to lower their costs related to the hardware. And again, to the right, as you know, you understand the pattern. Left is more new things. Left is the usual standard issues that we try always to handle, which is interoperability, support of IoT, security, etc. Now looking a little bit more into how we are approaching the different parts of the network, and starting with the RAN and some of the considerations is first we will not necessarily have backward compatibility, and that's in order to really have a full potential of 6G. So non-backward compatibility doesn't necessarily mean a complete disconnect with 5G. As you can see here, we are still saying that for certain characteristic, waveform, modulation, etc., this hopefully will be based on the 5G NR. RAN will actually approve the study item in June, in about 2 weeks in Prague. And the goal here is really to study if we need a new air interface or not. And what we say here is we will only adopt a new air interface if we show a significant gain. What significant is, that's another question, but only if a change will be only motivated if we have really a good gain here that would justify another investment on changing the equipments. Lean and streamline that I already covered. Coverage become again a very important subject to tackle, both by the integration of NTN with terrestrial networks, but also with the terrestrial having the coverage as a preoccupation from the start, especially for the uplink. And again, extensive AI/ML, building on what I presented for 5G. The idea is to have a native support for AI/ML from day one. For the core network, as I mentioned, one lesson learned from 5G is the standalone approach, which was not successful. So here there is a clear preference to have a one single standalone architecture for 6G. For the migration, so there are some considerations here, as I mentioned, one single standalone, but also have some multi-rat spectrum sharing between 5G and 6G, as well as the carrier aggregation for 6G. And dual connectivity and dual stack between 5G and 6G. For the interworking, so we assume a seamless interworking with 5G, but not with the legacy systems, except for 4G, where it's still a question mark to be answered if this is to be supported or not. But the general consideration is that to avoid interworking with 4G. So we are assuming an interworking with 5G as the latest legacy system. And finally, some considerations on the spectrum. Of course, we want to support the existing ones, FR2 and FR3, but a lot of interest on the upper mid-band is there, and this is believed to be really critical for the 6G. When all this is happening, that's the other thing I wanted to cover. This is the timeline. As you know, 3GPP is working in releases, and release 20 is for the study item. So we are not doing any specifications. No normative work is done for the 6G in release 20. And the round one, which is responsible for the physical layer, is expecting to finish their studies by March 2027. The normative work will take place in release 21. We haven't decided yet on an exact timeline, and we don't have an exact date when that will be happening. What we know is that will not happen before March 2029. So the goal is to be on time for the submission to the ITU, but it will not be ready before 2029 March. Final agenda, and again, I promise I will be very, very quick on this one. That there was another workshop organized by 3GPP with ORAN in ETSI. This is again the official summary, but I'm not going to cover a lot of it here because of the sake of time. I just want to focus on this slide. There are more, and if we share the slides, you can look at the detail. But I think the fact that we had the workshop in itself, that's the first workshop between 3GPP and ORAN. It's sending a very, very positive and strong signal that the two organizations are committed to work together with a common understanding and a common approach to how to develop 6G and have it a success. There was a very strong involvement on that workshop. We had about 400 participants, 100 on site and the others online. And again, I want to come back. The last point here is the fragmentation. This is the common understanding that we want to avoid the fragmentation, and we want to avoid the duplication between 3GPP and ORAN. So fragmentation is really the one message here, again, on the technology, but we know, I mean, we can't ignore what is happening in the world with the geopolitics, and we do what we can to avoid that we end up with regional standards as well. And with this, I stop here. Thank you.
Thank you. Are there any questions to Issam? I have a question for you. Is 3GPP going to adopt the name FR3 to sit between FR1 and FR2? Or
I think that's in the scope. Yes, it's more, that's what I have been reading. Officially, nothing decided yet, but it's the understanding is that the band in between FR1 and FR2 will
be called FR3. Okay, good. Good that you confirm. Ivan?
Yeah, so regarding
the mic. So people at the back can hear you.
Yeah, this is Irfan from OpenAirInterface. You know, regarding this, the follow-up of this 3GPP ORAN, what's the, you know, how frequently are these organizations going to meet? When are they going to decide which one is doing what? Because there's still a lot of discussion going on regarding, you know, work that is duplicated. When are we going to know, for instance, that, you know, ORAN will just do this, this, and this?
So I couldn't cover all the slides, but Doug is here, probably is the best person to respond to this because he was actually co-chairing the workshop. There was no decision made on when would be the next workshop or how frequent. And on the mechanism, it was, I don't remember which slide it was, but we were talking about using LSs to communicate. And when on a need basis, the organization, as we organized the first one, when the members see a need that the two organizations have to come together to work further on that, we organize another workshop. But at the time being, there is no firm commitment to having the next workshop. I don't know if Doug has anything to add.
Want to comment on this, Doug, or are you going to speak about this anyway after?
Yeah, just very quickly, the summary that is captured here is going back to both organizations, RAN and SA plenaries in 3GPP side, and back into ORAN. It will actually be discussed in some depth at the ORAN face-to-face meeting in Fukuoka week after next, and in the RAN plenary. And then it will go into the study item efforts to inform the decisions. In most areas, the general feeling, the sense of almost all the companies present was the work is pretty complementary, and the divisions that have traditionally been there are fairly well understood and should work going forward into 6G. In a couple of areas, there's a few rough details that are still controversial, and there'll be some debates probably inside of ORAN and 3GPP to iron out those rough edges, or mixing metaphors there, to sand down those rough edges.
All right. Thank you. I guess in the interest of time, we should stop here. Let's thank Issam again.
Thank you.
So we have a coffee break now, and we resume at 10. Wasn't it 10:30? 10:20. Okay, that's fast. Okay.
Now I'm going to present our next speaker, Doug Nicely, or I would say Douglas Nicely. Doug is working at Qualcomm. He's a senior director of technical standards at Qualcomm, and he's also an advisory member at the board of OpenAirInterface, and also leading. He's the co-chair of the ORAN Alliance Standard Development Focus Group. And today here he'll be talking about the next 10 years of OAI. So Doug, after you.
Do I advance it? Oh, okay. Thanks. Yeah, I don't think I'll be taking a full 30 minutes here, but I just wanted to talk really more about the evolving mission for OAI as we look forward, looking at the last 10 years and then looking forward to the next 10 years, and how things are kind of at a profound point of transition in terms of how OAI is going to serve a much more important role, I think, in a more complex ecosystem that is emerging. And so I just would summarize some of the accomplishments of the last 10 years, talk about the new challenges that are emerging, and how can OAI step up to meet those challenges, which is not an easy question, and the answers are not obvious. There are multiple choices, and we'll have to see how that plays out. And then thoughts on where we go from here in the future. So as was reiterated yesterday, I won't repeat all of this. OAI has moved, as Florian laid out, from lagging in the 4G area well behind the standards to implement something in an open source form that was already well understood and well deployed in the field and in the real world, to being, I call it, to when the stack was fully functional and ready to go, maybe 5 years after NR deployments were well underway for the 5G work, which is pretty good. I mean, quite a major improvement, and it still serves a purpose in a profoundly useful time for R&D purposes, and especially academic research. But now, as we all know, OAI is stepping into a role of enabling 6G academic work and research well before standardization is even underway. People are playing around with OAI to look at concepts today, and 3GPP is just starting their study item phase in June and for the remainder of this year. And nothing really substantial is going to happen until early 2026 in 3GPP. And ORAN, doesn't even have an official work plan at this point to when they're going to kick off official 6G work. But some of the things based on the success story of OAI, there have been surprising bonuses along the way that I think couldn't have been envisioned even with Raymond's wildest dreams at the beginning. in addition to the sort of core G Node B and radio and core network stack, there is a rapidly maturing UE stack that is becoming incredibly important now that we're starting to look more at end-to-end testing and cloud-based at-scale simulations and modeling and for applications like digital twin. There's also OAI has also evolved to support a wide diversity of CPU platforms and a wide diversity of hardware accelerators, which has been a real benefit for various applications of the code to different use cases. And then what has become increasingly important over the past almost 7 years or so is sort of the open RANization of the radio stack. And with that came cloudification. And so now going beyond basic packaging and issues like that into work at the initial levels within Nefio project to make OAI a native RAN stack within the Nefio project has really profound implications in terms of applicability for end-to-end orchestrated and managed and automated systems work going forward into the future. And then OAI had the foresight to make a big pivot into Open RAN support, joining ORAN Alliance very early on. Were you there at the very beginning, or yeah, right in 2019, and now stepping up to an active role, actually, with Irfan actually co-leading the open source focus group that's responsible for the overall open source strategy in ORAN Alliance, which is one of the cornerstone goals of Open RAN Alliance, but also deeply engaged in testing projects and OTICs around the world and to different levels, and engagements with our testing friends like Viavi, who was here yesterday and has now joined the ORAN board. But then that has also led to the rather rapid development of open source versions of Open Fronthaul, rather than just basic 3GPP capabilities. The RIC, OANM hooks and interfaces, and even some glue code and basic versions of OANM functions to support integrations into those blueprints, cloudification, Nefio, and so forth. So OAI has changed the industry in really profound ways. It's quite amazing, and I think OAI, everybody involved with OAI should be very proud. Some things that are not surprising is that OAI has become the de facto research platform for universities around the world. There are others, and it's mixed and matched with other component technologies, which is good and one of the overarching goals. Other implementations of core networks and RAN stacks and things like that are not enemies. It's all good. More open source research tools that are available, the better for the industry. We've seen the code is now to a greater extent facilitated or used in commercial products, and I think there'll be more discussion of that later in the session, so I won't really get into that. But the best part is, I think the impact of OAI is broader than we even imagined, because it's open source code, and we don't know all of the organizations that use it privately and even in product commercial applications that have taken down parts or major chunks of OAI code and are using it every day, and even in commercial products. But most significantly, and this is the of a couple of major benefits to Qualcomm. One of the major benefits is OAI, as was mentioned by Tommaso yesterday, OAI has reinvigorated cellular radio research programs. Because the simple fact is you just can't do research in this stuff if you have to build or access some kind of a version of source code that you can modify, if you have to pay for commercial code or write it from scratch in a university program. It would take much more than an entire master's and PhD program time to build up that base of code. But OAI has now made it feasible And even things like OAI Box and platforms that are meant for academic application have enabled projects to support students with a starting point where they can launch into their research topic from day zero with a fully understood and documented and working platform. And this has created a positive feedback cycle where contributions come back in from academia and even from industry. And selfishly for Qualcomm and I think other R&D companies, we can hire talent that even 8 or 9 years ago had dried up in research programs. Also, the intersection of AI and RAN and radio has reinvigorated some special niches to draw some good students away from just computer science and AI programs back into radio-related programs. And perhaps in new areas like management and automation and things like that in different programs. So this is really good for us and really good for the industry. So why has OAI had this effect? Well, I just want to flatter the OAI team. In addition to profound technical skill and coding expertise and radio knowledge and all of that, OAI has established a reputation by consistently being available to support almost anyone that reaches out to get support to use OAI in their project or to get new functionality or features and things like that. And OAI has been agile and flexible to pivot in new areas, right? When Nefio came along, OAI could have, OAI as an organization could have pushed back and said, that's not in our mission, we don't have staff for it, but Sagar and other resources jumped right on it and did Nefio almost overnight, Nefio integration. And so this combination of profoundly skilled radio expertise and computer science and cloud expertise and also an understanding of the industry is a very unique combination. And I think OAI, overall, should be very proud of what's been built here. Also, equally importantly to the industry, OAI has proven that an open source community model can thrive and become economically sustainable, which is a problem for the vast majority of open source projects out there in the world. And it's in a difficult domain that requires a good bit of money to keep the program going and a lot of special equipment and a lot of commitment to make this happen. And, we want to reiterate, Jimmy and others who've made this point, that one of the big enablers for this, aside from the profound technical competence and good attitude and good people skills of OAI over the years, it has been this permissive license that is suited for the radio domain to allow OAI to be tightly integrated with 3GPP community, with ETSI community, with ORAN Alliance community, and to gain support and to have a board that has all of these major companies that normally might have some IPR concerns if it were not in a correct framework. And I think this license is profoundly useful to the open source world and to the applications because for all usage purposes, it's Apache. And the IPR protection helps universities and companies that do research and development and have IP be able to work with OAI. And I've already mentioned the sustained outreach to industry standards organization is quite unique for an open source project. Irfan, in particular, has made tremendous effort to reach out and participate and engage and even take leadership roles in things like doing workshops with ETSI in the past, and I hope we'll revive those and maybe with 3GPP going forward. Tie-ins with the Small Cell Forum to become essentially the most prominent open source development arm of FAPI, and all this work with testing and integration centers in different organizations. But now we're at a turning point, and this is sort of the key that I want to get at. The rate of profound changes that OAI has gone through so far has been increasing exponentially. It was a little bit of a slow, graceful process from LTE to 5G, and a number of years to develop full 5G functionality that was really easily usable and as production grade as it is. But all the way to more sophisticated features, like now we're on the cusp of support for 32 by 32 and even 64 by 64 massive MIMO, and the introduction of a much more complex core network in 5G, which doesn't buy you very much when most of the application is just mobile broadband, but yet OAI did it and built all of the key interfaces and all of the key elements of the core network to have at least one version of everything that works and implements all of the 3GPP architecture. And then, as I mentioned before, the soft UE, of course, which is extremely important, and I'm so grateful that Nokia and Ericsson have stepped up support for that. But then in the last 5 years, going to a complete O-RAN transformation into an O-RAN framework, and especially Open Fronthaul, which is a huge accomplishment, right? It's actually a really advanced amount of functionality with now CUS and M-Plane, right? I think we have the full thing. I don't know whether we've yet passed the full certification tests and everything like that, but you know, for all practical purposes, you really have a reference version of the full Open RAN Fronthaul. The RIC, the OAI RIC, and the integration with other RICs, at least 2 or 3 other RICs out there on an ongoing basis. And now the OANM and OSC integration work with the ORAN software community. And as I mentioned, the cloudification stuff. But suddenly in 2025, that exponential growth has turned into an avalanche, and OAI is kind of facing being torn asunder because there's been a profound shift in R&D and commercial interest in AI/ML impacts on the RAN, and as we all know, and we've heard, you know, in almost every talk, the sudden demand for a complete automation framework for, you know, really basically our apps and all of the underlying glued to the RAN stack and all the hooks to enable experimentation and research in that area, AI-driven automation framework and digital twinning, you know, the connection with NVIDIA and the integration with Ariel and Siona in various research projects has a really profound impact, but a huge amount of new work that has to be done. And more hardware platforms are coming all the time. ARM, every form of accelerator, DPU, NPU, GPU, and cloud platform architectures, right, coming at us. Fortunately, we're getting contributions in OAI of hardware platforms to port onto, but there's a lot of platforms to do CI/CD and integration and difficult porting work onto, you know, low-level programming for those platforms. And then there's serious demand all the time for advanced 5G features. You know, now everybody said, well, you have a good basic solid 5G stack and can talk to commercial UEs and do testing at full rates on 100 megahertz channels. Where's the massive MIMO? And numerology increases and fan out to multiple DUs connected to a CU and so forth. Handoff, larger channel sizes, more layers, higher data rates, all of that is a lot of work that a simple reference platform for doing lab work in universities might not necessarily need many of those things, but now it's being pressed to be almost kind of commercial type scaling and numerology of the OAI code. And then at the same time, government research projects and industry and applications are asking for all of the 3GPP features that aren't even in commercial products in many cases. IAB, Sidelink, NTN, and there's either associated projects in partner companies or direct work in OAI in most of these areas. You know, that's happening more and more. And then research interest, of course, in next generation. We know about DApps coming out of NEU, RAN core network convergence, service-based transition of the RAN, and ideas that are being advanced in ORAN Alliance, pre-standard, that are being talked about and shared by companies in the next generation research group, in ORAN Alliance and so forth, where OAI has a presence, especially through Northeastern and also direct involvement in the ORAN process. And by the way, everybody, especially government agencies around the world, want all of this to be secure, performant, and bug-free. So it's like the whole realm of commercial requirements are being thrust on OAI, and it's like the same core set of people with only a little bit of growth. And so what we'll get to is how are we going to scale this thing, and how are we going to build financially and economically sustainable and manageable structure to implement part of these features and all this stuff that's being demanded. And I'm not even going to get into Okudu and all of that, which those who know is a whole another mess that's asking for everything on this page and more, and to be done, on a very tight time frame for not very much money. And there's, competition. You have to fight to win that effort, anyways, if that's even the right thing to do. So how can OAI meet these challenges? Well. The team as it's currently, I will assert, as great as OAI is, there's no way for the core OAI radio integration and testing efforts and the associated development efforts at Eurocom and partially in OAI itself can meet all of these needs and requirements on this schedule. So how can we accomplish this? Nobody has the answers, right? We're looking at a lot of options. There's a lot of discussions in the board and in and outside of OAI context to say what can we do. But it looks like we're going to have to make a dramatic growth in the community, right? And so that means finding a way to scale from a sort of friendly, manageable, compact project into something that is, I was saying offline, it's not Linux, but maybe it's Kubernetes in scale, right? It's a big project. I mean, we can imagine, it's not inconceivable a few years down the road that there'll be a OAICon, major events where instead of 100 people go, 1,000 people may be attending, and all kinds of effort and interest in use and contribution. But at the same time, we've got to make sure that that the core team can be sustainably funded to provide the architecture, management, and control, the integrity of the basic stack, and the radio integration and testing functions that require very special expertise. So in a way, OAI will have to maintain control, but find a way to leverage a much bigger community financially and as far as contributions are concerned. Maybe a whole pile of money will come in and we can hire 50, 100 developers. That's probably unlikely that that's going to happen anytime soon. At the same time, we need to also ramp up the coding conventions to industry best practices, code provenance, security, scalability of the community, and so forth. And so I think many people know there have been discussions of, should we work with Linux Foundation, an organization that unquestionably knows how to run mammoth open source projects, but that may not be the answer. We don't know that that's an answer. That's something that needs to be evaluated thoroughly and figure out how we relate to that part of the open source world. At the same time, I think we need to sort of step back and maybe write a mission statement for the next 10 years of OAI. What is the soul of the OAI project? What is the core value? Is it academic research platform? Is it going to be an academic and commercial quality research platform? Are there two forks that cooperate and share a lot of code but are different? How are we going to do that? How does the stack evolve? How does it fit into the broader ecosystem of open source and commercial code components, like all of the cloud and foundational projects that are in Linux Foundation and CNCF and the rest of the open source world and the commercial world? And what pieces should we bite off immediately, and what are the short-term priorities? We're going to have to stay focused and not just go randomly after all the things we could be pulled after. But one thing's for sure, a strong central core leadership team is going to remain essential. And so we have to continue fulfilling that goal, which has happened brilliantly, so far in OAI, but it's getting to be too much for the resources that are available. So on the evolving mission, I would say that this core research mission might be evolving and changing. We're going from a very good 4G, 5G stack to a comprehensive Open RAN platform, but now we're very clearly at a crossroads where the core mission is going to be something more like an AI RAN, and I don't mean in the AI RAN organization sense or the formal use of that term, but an AI native RAN, if you like, structure. That's the central focus of the research communities and the commercial applications going forward. It seems pretty obvious. So, and at the same time, there will be more ongoing pressure and I think value for government-funded and commercially funded driven applications of this code to add some of the more the less common 3GPP features like NTN sidelink, peer-to-peer features, and 6G use cases. So some things, that certainly need debate. I would say, although it's painful, I think the foundation stack needs to transition into a much bigger, more open source community that is going to be able to leverage more resources, bring more to the table, and at the same time, we have to expand the outreach to government, industry, academia, and so forth more, and be successful with bringing in the financial resources and the contribution resources into OAI to do all of the work that is ahead of us. And I think OAI itself, the vision for OAI, should evolve to be this broader, automated AI native RAN. At this point, and maybe even a broader vision than that, if we can look even further ahead at what's going to happen with the evolution of this kind of cellular technology, which is much more than just small cells in an office, and now is NTN and drones and all of these other use cases, which are profoundly important. And I think OAI is definitely on this path. But we need to find the resources to make this sustainable. And I urge everyone, I challenge all the companies to find a way to support OAI in this mission, probably financially, literally, because that matters. And if we can put OAI on a firm financial foundation for the next few years, and that's clear that we're safe in that regard, then I think it will make it much easier to decide technically where we evolve and what resources are going to be available to do this. And while everything that we're now facing and everything that is being done now would have been inconceivable 10 years ago, that's where we are. That's what we're doing in OAI. And I think I personally have kind of blind faith that OAI is going to make this transition successfully. And I'm a believer. I think Qualcomm is a believer. We're having a broader base of support in Qualcomm than ever because of the mission on multiple levels. And I want to extend the challenge to other companies to deepen your commitment to OAI in all dimensions. Code contributions and support work like that is great. Money is great and flexible. But I guess on behalf of the OAI board, I would say we need to step up all collectively to make this vision happen. And I think we can do it. So that's it.
Thank you. Thank you so much, Doug. And another thing, when I was introducing you, I didn't really mention this, but you have been a firm believer of OAI since years, and you have always taken it forward everywhere. So you have played a really big role, and thank you so much for that.
It was a leap of faith when I convinced us to join. It was just me who saw something there that I thought was profoundly important, and I'm glad I bet on the right thing.
I think you really did. And so we're running out of time, as always, but we do have time to ask a question or two. Somebody would like to ask a question to Doug? Anyone? I think it was pretty clear. That's very nice.
Okay.
Thank you so much. So, thank you. So with this, yeah.
This one? Yeah. I was told I need to be
You can take the, yeah, you can take this one, yeah. Yeah. So with this, I would like to present our next speaker, Florian Kasselberg. I think you already met him a lot now. So Florian is a professor at in the communication department of Eurocom, and he's visiting right now Northeastern University, and he is working in OAI since its inception, even before it, even the time when they were Express MIMO boards, and he's also a contributor. He does make a lot of commits in OAI, so his name is over there. So, and I'll let him introduce his talk.
All right. Thank you, Sagar. I've not been there before the inception of OpenAirInterface, so I only joined Eurocom 18 years ago. So OpenAirInterface was already there, but it was the start of of 4G and the start of the of a good journey. And today I'm going to talk about. So we're going to shift gears. It's going to be more technical now. I want to talk about joint communication, localization, and sensing with OpenAirInterface. So I'm trying a new acronym here, GCLASS. So I'm adding this L in here. I hope it might stick, because I will try to convince you in this talk that localization and sensing are actually related, and one is the evolution of the other. And I think that the work we've been doing on localization here can be evolved into sensing, and I'll try to make this point today. So I'm, as Sagar said, I'm currently at Northeastern on a sabbatical. This will come to an end this summer. I'll move back to Eurocom, and this work was done jointly with Northeastern and Eurocom and other partners as well, Firecell, TU Dresden, and TU Dresden as well. Well, to motivate my talk, I don't think I need much motivation, but you see that for 6G requirements, both sensing and positioning is there as new capabilities. I think it's important to start working on those already and be prepared for 6G. A bit more in detail, we've seen some study items in release 19 about integrated sensing and communication. So they have identified use cases for this field, and they also started to specify the functional performance and requirements for JSEC. And as we've seen also in the presentation of Isam, also on localization and positioning, there's work ongoing, so that they're trying to include support for AI ML algorithms in the specification. So this is just a list of those use cases that they specified for ISAC. So I'm not going to go through this, but just to give you an idea that there are interesting and important use cases for this out there. All right, so I'm going to first talk about the existing work that we've done in the last 1 or 2 years. First about the localization architecture in general, that's already there in 5GNR, what we've implemented in OAI, and then I want to transition to another architecture that can enable joint communication, localization, and sensing. And I'm going to give 2 examples that we've been working on recently. One is supervised and unsupervised learning for localization, and radar sensing for enhanced channel estimation. All right, so this is a very simplified picture of 5G architecture for localization. So already in release 15, they introduced this localization management function in the core network that handles all of this, the work. and they introduced they introduced one new protocol, which is the NRPPA, which is a protocol between the LMF and the G0B. So of course it doesn't go directly to the G0B; it goes through it's tunneled through the AMF. And there's also the LPP, which is something that they took over from LTE. It's actually called the LTE positioning protocol, but they adapted it to 5G in release 16. There are a lot of different methods that are supported in 5G&R. So there's even methods, hybrid positioning methods that take other sensors into account, like GNSS, Bluetooth, or Wi-Fi. But here I'm going to focus only on the methods that use 5G signals only. So there's TDOA, so there's enhanced cell ID, TDOA in the uplink, TDOA in the downlink. They have introduced something called multi-round trip time. And in the different releases, they all kept on advancing this to positioning when the RSC is inactive, on-demand positioning reference signals, improvements in latency and accuracy. And now with release 18, they also support RedCap, carrier aggregation, and side-link positioning as well. So I'm going to focus here. So what we did is uplink TDOA. So uplink TDOA uses the SRS sounding reference signals that the UE transmits on the uplink. And multiple G0Bs participate in the localization, so they listen to the SRS, and they estimate the time of arrival, the relative time of arrival. But since the UEs are not perfectly synchronized to the network, they only have relative synchronization, we can only exploit the time difference of arrival. Okay, so if you compute the time difference between different G0Bs or different antennas, you get hyperbolas, and the localization is the solution of the intersection of these hyperbolas. So this is a picture of the protocol, the NRPPA protocol, between the LMF and the G0B, the serving G0B as well as the neighboring G0Bs. So I'm not going to go through this. It's just to show you that there's a lot of steps involved and a lot of elements involved. So even the AMF, since it needs to tunnel the messages, it needs to be involved as well. So this is just to show you that all of this protocol has been implemented in the G0B. So in the G0B, we did the SRS estimation was already there, and we put in the TOA estimation. We added the NRPPA functionalities. We did the adaptations to the AMF to support NRPPA, and we have this new element, which is the LMF, which is actually contributed by TU Dresden. So that was done in a joint project. We integrated some. So, for example, this uplink TDOA algorithm was integrated in the LMF, but it is written in a way that people can plug in their own algorithms. For example, we did also work with Fraunhofer, where they have another algorithm which they run on their premises, and we can interface with that through the LMF as well. And then there's an API, an external API, so that an external application can query the LMF for position of the user. All right, in terms of algorithm, so this is mainly my PhD student, Mohsen, who has worked on this. So one of the first algorithms that we tried was is based on particle swarm optimization. So we have to solve this system of equations that's determined by these hyperbolas from the TDOAs. And there are many ways to solve this. There's classical least squares, and then there's more advanced. And one of these more advanced is this particle swarm optimization, which generates a set of particles, an initial possible solution, and these particles have a velocity, and then it's an iterative algorithm that tries to find the best solution. And we have done experiments. So these experiments have been done at Eurocom. You might recognize this building where we had the workshop last year. We deployed the RUs, 3 RUs, 2 on the higher roof and 1 on the lower roof. They're all connected to the frontal network at Eurocom, to the switches in the server room. And the special thing is that we did is that, so each RU has 4 antenna ports. We use external antennas, and we use long coax cables to distributed antennas, because in order to get good accuracy with the TDOA, you need a distributed antenna system. And then our experimentation area was the other roof, the terrace there, and we with a laser, we labeled some locations to get the ground truth to evaluate the performance. Yeah, these are just some pictures. We use these small antennas here on the lower roof. The big antenna you see on the left roof is actually not the one we use for the experiments. That we use, you can't really see it here, but there are cables that run to the railing there, and we fixed these small antennas on the railing on the top roof. All right, so these are some results from the TDOA. So you get actually I think I have a CDF later when I compare it with the other algorithms, but you get in 90% of the cases, you get sub-meter accuracy, which is actually quite good and comparable to the state of the art with this method. And you can get a live view of the position of the user through the API. And I don't have the video now. There's not enough time, but I showed it yesterday in my demo. If you want to see it, I can show it to you after. We also done, so FireCell mostly has also then taken this setup to other locations. So the location at Eurocom is actually turns out quite nice in terms of propagation, because you have mostly line of sight and not a lot of multipath. However, if you take this indoors, which is the real use case, then you have to deal with more multipath propagation. But nevertheless, after a bit of tweaking and improvements to the algorithm, we got this to run there too, and the results are a little bit worse than outdoors in the good propagation, but they're still acceptable for many use cases. Not for all use cases. Some people want even some use cases require better accuracy, but you know, I mean, one use case is big factory halls use you know, tools. And believe it or not, people displace those tools and sometimes can't find them anymore, and so they need to relocate those tools, and you know, a meter or two accuracy for this kind of use case is enough. All right, so now let me come to the newer part of the work, where we try to now integrate AI/ML into positioning as well. Of course we do, because we have to. And so there's one problem with this, because until now NRPPA does not support the sending of the full channel estimate to the LMF. And for AI/ML, that's what you want to use. You want to use the full SRS channel estimate from multiple G0Bs and multiple antennas to train and then to use your algorithms. So we can't use, at least for now, the NRPPA for that. So we decided to use the ORAN E2 interface for that. So the E2, since it is already there in OpenAir, but unfortunately, what does not exist is a service model for the SRS. So again, that's something that probably should be done in ORAN, but it's not there yet. There is something else very recently that they did is the lower layer control service model. But it does not send the SRS channel estimate. It sends, basically, it forwards the SRS IQ samples that it gets from the RU. As it, you know, it's just an extension of the frontal interface over the A2. We could use that too, but we didn't want to, because then you have to do the channel estimation in the rig, and you have to get all the parameters of the RSC to the rig. So it was actually easier to use that custom service model that is there in OpenAir to export the SRS channel estimates from the DU to the rig, and here we use the flex rig, and we use actually what we to make it even simpler, we reuse the FAPI SRS indication message. So basically the layer 1, that's what the layer 1 uses to report the SRS to the layer 2. And since the E2 agent sits in the layer 2, we just take that and forward it directly to the near real-time rig. And this architecture is particularly well suited for these algorithms. I mean, it was designed for this because you have the near real-time rig and the non-real-time rig. So the non-real-time rig can be used for the training, and the near real-time rig for the inference. So this part we haven't quite done yet, but that is feasible too. All right, so for algorithms, the ones that we tried, we have two examples, one for supervised learning. We use simple fingerprinting. So we have basically you take measurements that have been labeled with the location, and you train a neural network to learn those. And the other method that Mohsen tried out is channel charting. So channel charting is an unsupervised method. That tries to that doesn't require labeling, and that tries to look into similarities in the channel state information. And there are also some non-line of sight mitigation techniques that he included. All right, I'm going to go a bit faster. So this is the CDF that I promised before. So the channel charting works pretty well. It doesn't work as good as the TDOA. So the blue curve here on the left is the TDOA. So this is again results from the testbed, same testbed as I showed before. The blue is the CDF of the TDOA with 8 antennas, and the orange is the channel charting with 8 antennas. So it is worse. However, channel charting works better in scenarios where you have less antennas. So if you only use a subset of the antennas, so for 4. So one RU with 4 antennas, and compare again TDOA, which would then be the green curve, with the channel charting with this red. You see channel charting more or less keeps the performance, whereas the TDOA is performing much worse. Yeah, so I have to mention that this implementation so the results have been, the implementation in the near real-time rig and the E2 interface is not quite finished. So this is a prototype using another protocol, using MQTT. But we've made good progress, and I believe by the end of the summer we should have finished that work too. All right, so now sensing. So this architecture can also be used for sensing. So the sensing can be done in different ways. There's monostatic, but this requires full duplex radios. There are demos on this too. There's a very nice demo, a demo video on YouTube from Qualcomm where they show this. Actually, they can detect drones using a full duplex radio, and using PRS signals that are sent from the radio, and then detecting changes in the channel state based on PRS. But I want to focus on the other scenario here, the bistatic and multistatic sensing or radar, which has non-collocated transmitter and receiver. Okay, so we can use actually the UE as a transmitter and use the SRS just the same way we use for localization to detect changes in the channel. Okay, it requires, the only problem is that this requires very tight synchronization, and there is work that my other student, Rakesh, has been doing on synchronization, tighter synchronization of UE to the network to allow this kind of sensing. All right, and the work and he applied it to channel estimation. So he did so after the sensing. So the sensing can estimate the location of the scatterers and their angle and their delays. And if you have this information a priori, then you can actually reduce the pilot overhead for subsequent channel estimates. Okay, so he came up with an algorithm to do that, and he tested that. Now, these were experiments that were carried out at Northeastern in Burlington. Well, he did some channel sounding measurements and then replicated the whole thing in MATLAB to test his algorithm. So this yet has to be implemented completely in OAI. And he compared his method with conventional channel state, and you can see that we can achieve the same performance with less pilots, or similar performance, or well, almost as good performance with the full pilots. All right, I think I should come to an end. Sensing is important. We need to make sure that OpenAirInterface is ready for that. And I think the localization work is a good starting point. We can reuse a lot of these functions and the architecture, because I believe the architecture is going to be an evolution of the 5G positioning architecture. I've seen already some, the sensing, I've seen already proposals for a sensing management function in the core network, which is probably very similar to the location management function. AI/ML algorithms are good for this kind of problem, but they require the full channels and information. So either we use the ORAN architecture, or we extend the NRPPA protocol to be able to get this information. And yeah, as you could see, OpenAirInterface is a good starting point for that work. Thank you.
Very nice talk. So, does anybody have questions for our speaker? Yeah, please. Ring.
Okay. Thank you, Florian. Actually, we have followed your work for a long time. And yesterday, after discussing with you, I also sent my students in Beijing to test the TDOA among different antennas. But they observe a very weird result. So we suppose that the TDOA between different antennas should remain very stable, right?
Oh.
No, yeah, it's not stable. Yeah, actually in ours, it's not stable too. So my question is, do you think it's the problem of the RUs or from the multipass problem?
So, so for the reason we use yeah, I didn't talk a lot about this, but we use ORAN frontal here, and we use ORUs for this experiment because they have, they're synchronized using the ORAN S-plane.
Yes.
However, but still, it's natural that the relative TOA that you measure within a single RU can fluctuate. So there are normal fluctuations,
yeah.
But the difference should not fluctuate. The difference between RUs. However, we did. So it depends on the deployment and on the switch. So there are differences in the quality. We realized in the different switches. So here we have a Cisco switch, but in the other deployment, I want this one here, I think there was a Fibrolan switch. And we could see much between RUs. Sometimes you get instabilities in the TOA measurements. Yeah. And it worked better with this setup, with the Fibrolan switch, than with the Cisco switch that we had at Eurocom.
Okay.
So this is a factor that is a little bit out of control that indeed we should understand better, but it's a
okay.
Yeah.
okay, thank you.
Difficult subject.
Please go ahead.
When it comes to positioning and sensing, is there something looking at MIMO, the risk controller, and what impact it can have on positioning sensing algorithms?
I mean, MIMO is definitely useful for positioning as well, because you can exploit also angle of arrival. It's something that we only studied in simulation and not in the real deployment. But if you have a large antenna array and you know how to estimate your angle of arrival, you can feed that into your estimation algorithm and get much better estimates as well. Yes, absolutely.
So that's somewhere on your roadmap to do?
Well, first we need to get the massive MIMO to work. But once that's done, we can include it in that work too.
Yeah, so now we have to go for the other panel. Thank you so much, Florian, for this interesting talk. So I would like to welcome the panelists for the next, this is the panel. Wow, there you had really a lot of slides, I would say. Quite so many. Yeah. So now we are holding a panel, which is how our business is leveraging OAI and other open source markets and opportunities. One thing I have to tell you that I'm really standing between your lunch, and it's my specialty. From past 3 years, I'm holding panel just before lunch. I'm going to wrap up at 12. So I would like to welcome our panelists. Paolo Marquez, he's the founder of AllBeSmart and also the company which is behind OAI Box. Then there is Navid Nikayan. He's the CEO at BubbleRun. Please, Navid. And then Arpad Yoza, he's the Chief Product Officer, Lasting Software. Thank you, Arpad, for coming. And Pedram Jory, he is representing ZTouch. He's a principal research scientist at Northeastern. And Laurent Thomas, he's CEO at OpenSales. And I'm Sagar Arora. I'm a solutions architect at OpenAirInterface. So thank you so much for accepting to be part of this panel and giving us the opportunity to hold this panel, because I think it's something very important that how businesses are really using the open source code bases, especially also OAI and other open source projects which are out there, and how they are commercially making a product out of it and able to make a business around it, which I think is really interesting. So what I did is that I made something known as a telco open source wall. I tried to put a lot of projects all together. I wanted to put the little penguin also there, but it's used everywhere, Linux, so it's indeed everywhere. So with this, I would ask you the first question for today. And it's for all of you, that what are the problems your company is addressing in the telco space, and are you using OpenAirInterface or any other telco open source project? With this, I would also like you to give a brief introduction about your company, that what do you do, your mission statement, so that everybody really understands. Paolo, please. With you.
Okay, first of all, thank you for having me here. When I created AllBeSmart 10 years ago, we are a company that provides mainly Wi-Fi deployments for smart city projects. So we start being the company that deploy networks, even optical infrastructures, which is good. We got a lot of experience on the field, but it was actually thanks to OpenAirInterface that we moved from a company that is a system integrator to have our own product line. So we provide the OAI box that is a end-to-end 5G test network that runs OAI inside. So for us, it was a huge value to have OAI, because we move from being an integrated company for a company that actually has a product. So this for us, it will, let's say, the grand advantage of using OAI. And today we are more focused on this niche market that is actually facilitating the use of OpenAirInterface for research and development. I think from my side is okay.
Yes. Thank you also for the invitation to this panel. So for BubbleRun, so essentially I was and I still working closely with OAI previously as a developer, now more as a promoter. My journey with OAI started by actually learning mobile communication systems, right? Because I didn't really have the background on this area. I was more like a networking person. So this ecosystem was quite fertile, being always confronted with different problems, software development, open source, understanding the community, what are the needs, what are the problems, what are the R&D problems people want to solve, what are the obstacles. I would say 10, 15 years ago, when we started 4G, I would say Eurocom was the only institution that is able to build the end-to-end 4G environment, right? Today, any place I go, everyone is able to deploy 4G and 5G without any problem. So I think this is thanks to OAI that people learn to actually use 5G. So from BubbleRun, we understood the problem of the community, And one thing that I want to highlight, we didn't want to take the position on whether OAI is better, SRS is better, or Amarisoft is better, or any other software stack. We kind of took the approach of ORAN, which is more like a neutrality in the 5G ecosystem, and try to build the ORAN stack, develop the ORAN stack by ourselves, and extending OAI with ORAN. So having an end-to-end solution from the UE to the core network based on different 5G stacks, but also having the ecosystem vertically from the RAP to the RAN function. And so today with OAI, you know, we are providing a very feature-rich system where the customers, they can really understand the, let's say, how the RAPs are working, how the XAP are working, how the automation in the cloud is working. So the pain of integration, that the picture that you're actually showing here, so we are actually taking the pain of integration of many of these open source that you're actually showing into one turnkey solution. So that's essentially our added value for, let's say, based on OAI and also other ecosystems.
Okay, thank you.
Thanks. Thanks for having me here. I think it's quite an honor to be on this panel. I was not expecting, I think I'm the underdog here, so thanks very much for sitting beside me here and in the middle, so I feel really protected. To answer your question, Lasting Software is a company which basically has quite a big history, as the name says it as well. It's a software company, so we kind of well, run away from hardware to a certain extent. We have our own, I think, I would say, logic behind it. We have a quite strong terrestrial network, pre-GPP-related background. But why it was very important for us to find OAI was because we just figured that after developing software in general and SAP and C++ and so on and so forth, why not jump into NTN directly? So if you do not have something like OpenAirInterface to help you with that, I think that would have been a nightmare. Yeah. So from that perspective, I think we owe quite a lot. So as you said as well, we own our basically product, the development and department to OAI. I'm here actually because of OAI. So for that perspective, I think we're very glad to have you guys. We are still, of course, working on a lot of the aspects that are hindering to a certain extent the NTN part of the NTN branch, let's put it like that, within OAI. But I think it's quite on the right track to becoming something much more than it is today. We are happy to also provide solutions and bits and parts of what NTN represents today. Small features, small functionalities. And I must say that based on the maturity level of OAI today, it has been accepted quite widely in a lot of the collaboration that we had so far. ESA is a big fan of OAI. We have had quite a lot of projects with them, so we are using intensely OAI as well. So from that perspective, I think we're on the right track. And again, good job, I guess. Good community. So I will pass the ball now.
Thank you.
Thanks. Thank you very much. I would like to appreciate the opportunity that we have here. A disclaimer, I'm just representing ZTouch Networks. The founder of the ZTouch Networks is Professor Tommaso Melodia, who had a presentation yesterday. I'm sure that he's well known here. The business of ZTouch Networks is essentially focusing on simplifying the deployment of the 5G networks in an automated fashion. The work was started, I want to say 5-6 years ago. The company was formed a couple of years ago, almost 3 years at this point. One of the key factors that I just wanted to highlight in terms of the benefit of using open source software in general for startup companies, I think it helps a lot with accelerating the innovation. especially when you're involved with some of the communities, such as OpenAirInterface, that has a really big community of all you people here and others around the world who are actively contributing to the code base. At ZTouch, we of course benefited from the fact that we had a code base that we could start developing our innovative approaches to automate the deployment, monitoring, and control of the smart 5G cellular networks. But at the same time, we have also contributed back at any time that we figured out that there are things that can be improved in the code base. Besides the OpenAirInterface, we have relied a lot on the OpenShift, which is another open source for the orchestration and the management of the network. On the RAN intelligent control side, it's primarily based on OSC, again, another open source resource that we had has been quite helpful in developing on the intelligent control side of the things. And as I mentioned earlier, I think it's a great opportunity to accelerate the innovation. Would it be possible without open source? Probably yes, but it would have taken probably 10 years for us to get to the place that we are right now. So I think that's the key benefit.
Thank you.
This one is working. So yes, what can I say? I would say that I completely follow the vision that Doug said before about the importance of OpenAir. In fact, what is good is that 3GPP standards are public. So compared to some other business, at least we have access to all the documents everywhere in the world for each people. But I was considering that it was not enough, and we should have also an implementation of that standard for everybody in the world. So it's what we have done in OpenAir. And at the time we created the Alliance, I said also, but open source, how do you make money with that? It's not that easy, because everybody can access everything for free. So I decided to create the company OpenCells to see if we can also get enough money for an organization to live on that open source. And so it is running for 10 years now. It is still a small company, but it lives and it contributes to OpenAir. And it makes, if you want, the business we do. So we do support to OpenAir like SIM cards, but SIM cards that doesn't make any revenue. It's very, very small. We make revenue basically by selling code development based on OpenAir to companies. So when we can, we put it back in the open source community. When we have customers that do a kind of legal interception, typically, we don't commit back because they don't want. We don't see it here, but there is quite a large community that use OpenAir for interception, for hacking, for whatever we believe is illegal, but it is legal because in fact, legal interception exists in public network, but you have to go to the court, say, I want to listen that phone. But let's consider that bad people have phones, but you don't know even the number. You don't know the SIM card. So you cannot go to the court and to say, I want to listen that SIM. So how do the police, military organization, they use OpenAir and they hack directly the network? It's legal. So that was one source of revenue. The other source is just to participate and to make OpenAir 5G. And now we start another story that is we believe that we need better SDRs. Now everybody continue to use B210. That is great, but that is 20 years old. And I think someone, so we try ourselves, but if we have competitors, we will be happy also to do new SDRs, more modern, faster, and so on.
Okay. By the way, your SIM cards are not making revenue, but they are the only one which are enabling everyone across the world. You know?
Well, on that, I think we'll stop now. We can buy Sysmocom cards, and they are good.
Yeah, please don't stop, I would say. So to go forward with the next question, the next question is here: how does OpenAirInterface and other open source projects you are using facilitates commercialization of your product?
Yeah, I think another important aspect of having been involved in this fantastic community is that a company like OBSmart, small company in the corner of Europe, thanks to the OpenAirInterface community, we can expose our expertise at top-level companies like Qualcomm, Ericsson, NVIDIA, that are members of the OAI Alliance. So in this perspective, I think OAI is actually democratizing wireless innovation. Because if you are actually good, you are writing good code, and you be involved and ask for merge requests and get feedback, so the community will realize your expertise. And then you are at the stage level with these big companies. So for us, and we also provide customization services. It's not just a wirebox. We have customers like AMD that request expertise from our engineers using OAI. And this is thanks to this platform that OAI has created, and that brings visibility for a small company in this big stage. So for us, again, it's very important to be involved in OAI.
Yeah, good question. In addition to what he said, I think customization is a key here. We could actually tailor OAI to different use cases, different customer needs, right? Because the code, I mean, we talked about the license, so which is permissive license, allows us to customize the code, sometimes contribute back, sometimes not contribute back, because it depends on from customer to customer. But one need that we found is that customers, they want to have an ownership. They want to have a uniqueness in what they are having. Although the code, the fundamental code is based on OAI, but there are some needs to customize, to add some specific features. Sometimes, for instance, they want a specific accelerator, a specific hardware, a specific, let's say, functionality, feature development, consulting. So this actually, OAI is a quite enabler for that, as opposed to other open source platform, to be able to build this custom solution, right? And obviously exposure, community, trust is also good ingredients here.
And after the custom solution is built, then basically you are able to also dab into whatever it is you're doing or what we are doing, which is testing, validating. So certain tools that we have developed actually are facilitated to work as they do today because, you know, you had some interest or some customers who wanted some specific features in NTN. Those have been implemented quite quickly, and then we are able to test it. So if you would have waited until somebody put out a healthy, mature 5G NTN code out there and then start working on products and solutions, well, then we would have had this conversation maybe in 27 or 28. It is 25, which is quite good from that perspective. I think that is one of the great aspects that need to be said here is the fact that, you know, everybody's quite open to discuss and to work on this. We have a lot of debate, a lot of discussions with a lot of companies, including, you know, some of the guys who already put out, you know, software which is, you know, quite mature, like SRS, for example. So we had quite heavy debates with them, and then, you know, put OpenAir and their software head to head and see what's what. So from that perspective, it's great to have something like this at hand. Again, I think the next step is to see whatever the market is going, have the same agility to introduce the new features and new functionalities into the OpenAir interface code, and then to, well, test it. And then, by the way, you need to stop me from drinking more coffee. I'm seriously, the coffee is too strong here. Really? Look at it.
Oh, wow. I think, yeah, Italy.
You need to put more water in there.
Yeah. You have to, rather than Italian espresso, probably going to go with Americano, which has a lot of more water in it.
Yeah, I think you're right there. Yeah.
I think all my colleagues here have already mentioned all the great points. in terms of course, getting exposure, having the support of the community, and contributing back, of course, is another factor. But I wanted to highlight, again, one key factor that I think helps a lot in a startup setting. And that's the fact that you have a vision. For example, at ZTouch Networks, the vision is automating and simplifying deployment of 5G networks. So you start developing some tool chains and pipelines and frameworks to achieve that goal. But at some point, you need to do some proof of concepts and demonstrate that this actually works. If you want to do that with proprietary components, such as the RAN, RICs, and alike, or network orchestrators, that's going to be quite challenging to build the trust at day one so that you get access to some of those code bases and start developing your new ideas. But with the open source code bases, everything will be accelerated. So you have access to all the components that you need. You can start developing your new innovative ideas on top of that. Then you can start, as was mentioned by the other panelists, you can start exposing that to the community, showing that the new capabilities that you have created. You can do demonstrations, and then I think you start developing the trust and the fact that, okay, there's value added with the ideas that you have in this startup, and then that will attract the attention of some of the other companies. As an example for the ZTouch network, of course, it started all around the base of OpenAirInterface, OSC, and OpenShift. But right now, it's at the level that can be integrated with proprietary RAN intelligent controllers, orchestration frameworks, and alike, which would have not been possible without having access to open source software in day one.
So what is the question?
Like how OpenAirInterface and other open source project is facilitating you in your business.
Oh yeah, okay. Well, you cannot make a lone 5G standard. It's just something that was accessible to Ericsson, Nokia, and so on, that have about 2,000 engineers focus on only implementing the standard. So there is no other choice than using a big open source or closed source, but an implementation of the standard that come from outside. It is the only solution.
I mean, if let's say OAI would have been there, what could you have done? Everybody has to write things from scratch, like as everybody said, right?
Well, I don't know. For me, it's chicken and egg. I made it.
So here's going to be my last question, and after that, I'll open the floor for everyone to ask questions to our panelists. So, as we all know that open source. So, open source needs you, and you need open source. It's a two-way relationship, right? So, how do you think that companies, businesses, mostly let's say businesses using OpenAirInterface, how they can give it back to the community, in what ways they can do that, so that the open source model is sustainable for the upcoming future?
If I can start. Here you go. Yeah, it's a great question. So our experience in commercializing the OAI box, so today we have more than 100 boxes across the world, even in Sydney.
That's
but thanks to this customer support also that we give, we get a lot of feedback from OAI users that are using the box as a way to facilitate the use of the open source code. But we have, let's say, ticket systems, and a centralized point, we get feedback from a lot of users of OAI. I would say that maybe half of them never used OAI before, without the OAI box, without the abstraction layer that we have built to facilitate the use of the code. But of course, we would like to give good support to our customers. So if there is a bug, we try to fix the bug in the OAI code. And we are also committed to improve the quality of the code. So everything that is 3GPP related goes back to the public repository. I think it's a good example how commercializing a solution based on OAI can actually improve the quality of the code.
Yeah.
And And yeah, we're very committed with the OAI, not just for the RAN, also for the core network, for the we have different use cases. So for us, I think it's a win-win relationship that we'd like to keep. And yeah, with this, I pass to Navid.
Yes, thanks. In addition to what's said, I think, as you mentioned, it's a two-way channel, right? From this startup's perspective, Bubble Run perspective, we kind of trying to expand the usage of OAI and the use cases, right? So for the moment, what we are interested in OAI is really the 5G stack, right? So the RAN and the core and the UE. And based on that, we can build a variety of the usage scenario. For instance, one work that I can here highlight, my colleague Jerome is here. So we did a joint use case on V2X 2 years ago for Mobile World Congress, right? So we could work with other colleagues that they are actually working on different domains. You know, in 5G, we are talking a lot about, okay, enabling business or, you know, having the use cases. So this type of collaboration actually is very much useful to show to the world that, okay, there is a new use case for using the OAI ahead of market, obviously, right? Because we are not pretending, at least Bubble Run not pretend that we are having a carrier-grade product, right? It is a product for, let's say, R&D. It's a product for reference implementation for private 5G. We are not saying we have a production-grade solution for private 5G, but we say we have a reference solution for private 5G that someone could take and system integrator and take it to the next level, right? So we open channels through system integrators to use OAI to bring it to the client, or we bring new use cases for OAI, and obviously when applies contribution to the open source.
Thank you.
Well, that's about covers it.
Yeah.
Yeah. So feedback is good. If you use the tool, use the code, promote it to have as many users as possible afterwards. I think that would be an added value. Feedback is important, as mentioned. Use cases, for crying out loud, give us use cases. If you want to avoid this slow start for 5G, like it was a couple of years back, we need to really understand the use cases. So if you do feel like you have a good use case, come out in the open and tell us about it, and let's see how we can make it happen, right? And I think one more thing to be added here is that OpenAirInterface today is like WinRAR. It's like the good guy, you know. You can, contribute as well sometimes. You know, it's good, it's open, everything is free of charge, but maybe some guys who have better finances can also finance OpenAirInterface. I think that would be very good added value. Again, it's the WinRAR approach. I think it's a good approach, but you know, if you use it and if you're happy with it, maybe you can also finance it sometimes. So I think that's about it.
That's pretty much true, yeah.
You brought me back to 2 decades ago when you said WinRAR. That's a good touch.
Big fan of it,
yeah. Again, I think all the great points are mentioned already. But in terms of this two-way channel of contributing back, I think everybody who appreciates the benefit that the open source software brings to their innovation, they always do the good practice and then contribute back. Of course, there are people who may just use it and do not contribute back, but I think it's pretty much well established these days in the community that they do the good practice and bring it back to the entire community. Again, an example about ZTouch Networks. In early days, we started this platform. Many of you might have seen it. It's called OpenRAN Gym. And if you have not, I highly recommend that you will go ahead and take a look at openrangym.com. That's a completely open toolbox that uses some of the things that we have developed at ZTouch Networks. It ended up being a startup company later on. But it's around, the code base, of course, comes from OAI and others, and the RIC is highly tied to OSC. But it has a set of examples and guidelines for everybody who is interested in learning about AI and RAN in general. I think as of today, there should be around tens of tutorials with different applications, such as slicing, traffic steering, and things alike. That we have put up there for everybody to use. And you can either put it on the platforms that we have, the testbed platforms that we have at Northeastern, or you can just simply put it together on a bench that you have with P210s or other software-defined radios and have it up and running. And on top of that, you can develop your own new tools. So as I said, and as all the other panelists mentioned, I think it's good practice to appreciate the benefit that you're getting from the community, and always, in a goodwill, get it back also to the same community.
True, yeah. I'd say any sort of contribution in open source matters, whatever it is. It's like even just reading a document, like reviewing a merge request, I would say buying me a coffee, everything just, everything is a contribution. Long.
Well, yeah, but we can see that in the last 10 years, it's relatively hard to find enough money, find enough people to work on it, and it's always a challenge. Doug was saying that before, and it's true that it is not so easy to bring enough people and money when you can get everything for free. It's a permanent challenge.
That's true, but the things remain for free up to a certain extent, because after that, everything gonna drain out. So it has to be sustainable, right? So that's why everybody have to give it back, and then also take it.
Yes, and especially in Europe, there is too much people that believe that money always comes from government, and we should also find out proper resources that doesn't come from taxes.
Yeah. Okay, thank you so much. Thank you all of you, for this beautiful discussion. And I will now open the floor for everyone to have. I'll keep it with you. I'll take that. Sorry, yeah. Here you go.
Thank you. So one note about what we were talking just now is you need to use community more. Meaning, one thing is coming back from people using your tools are basically low on cash. So the cash is the hardest thing to give. Yeah. We can give time, we can contribute code, we can contribute stuff. But things that can speed you up probably is hackathons to do specific items of the code. And second, you said buy me coffee. There's like buy me coffee option on your website, buy me coffee, or crowdfund for a server you need in your lab. So there is community ways to get, and even for a company like us, if we give like $100 or $1,000 to your PC, I can do that, but I cannot oblige to pay something indefinitely.
See, what I would like to also emphasize was mostly, it was most that, thank you so much for that. But it's also, what is actually needed today, and most of the open source communities are there. It's mostly the code contribution and reviewing the things. Not even certain communities have been part of, they don't even need code contribution. They need most people reviewing what's already there, so that, and document. Yeah, that's true.
The best way to get an answer from internet is to challenge, right? State something like this is a challenge.
Yeah. That's a nice approach, thanks. Anybody would like to add anything?
Yeah, it's a good idea to turn it into a kind of game, yeah. I agree.
Okay, that's really interesting. I'll think about it. Any more questions? Yeah, please. Yeah, there you go.
Yeah. No, I agree with you, this crowdsource. Even Wikipedia puts out a request for donations and we all donate. So I don't think there's anything wrong with that, right? So, but what I wanted to ask the panelists is that what are the steps they have taken to ensure that they are compliant with the 3GPP FRAND? And is there some percentage of the revenue as they are going commercial deployment that they are paying as licenses for the people who are holding the SCPs?
It's a really interesting question, I would say.
We are so small today. I think they will come knock the door when the revenue exceeds certain amount. Until you are below certain amount, they will not be interested in, I mean, obviously our usage is not commercial deployment, right? It's R&D today, right? So when you go to the commercial deployment and when you have certain, let's say, revenue, then there are certain companies that they will naturally come knock your door. But I'm not the right person, obviously, to answer this question. But today, Bubble Run doesn't pay any euro to any company for IPRs.
Okay. So maybe there needs to be a strategy on that, because we have had some companies which were, the minute they hit the revenue point, they did not, they had taken no act, they didn't know what to do. They were not aware what steps to take to safeguard themselves from that knock, as you said. But then the knock was so bad that they were killed.
I would say, I think at some point I was discussing with Raymond, you wanted to put in place some table of saying which patent on implemented in OAI, because we need to know, OAI does not implement everything, right?
Right.
There is a subset of those IPRs are implemented in OAI, and when it is used, you are, let's say, eligible to pay. So today, I'm unaware which one I'm using. So I think maybe this is a kind of a role for OAI or Alliance to provide those, no? I don't know. Who should do it? That the question then is, who should know which patent is?
Yeah, I'll take it. There you go. Oh, please have it there.
So, you know, when you're creating a company, it's your responsibility to do things right. Nobody else can do it for you. Right? You cannot say that a company died because, you know, something happened. I mean, they have to take responsibility of not doing that thing which killed the company, which I strongly advise all of you to do.
But this is more, okay, we can do, but this is more community. I mean, this would be useful for the ecosystem to grow anyway. I agree with you. We should take responsibilities, but again, if the ecosystem must grow, everyone needs to be aware.
Excuse me. So I considering the IPR, I got an idea. So maybe do you think it's feasible? For example, if you sell the OAI code, you need to deal with the patents, right? But as a company, what if you do not provide an OAI code? You just provide what you developed as a patch, or just you provide your own code, and the end users, they download the OAI to your box, to your machine. Do you think this will be feasible?
Yeah, please.
At the end of it, you just pass the buck to somebody else. Now that user has to understand, enter into FRAND agreements. Now the steps to be taken. So you know, besides the OAI license, there should be a asterisk which says, okay, here is the footnotes which will explain to you what you need to do to make sure that you are compliant with 3GPP FRAND.
Absolutely, but you know, and we are enabling that. I think we are doing a good enough job of giving to the businesses what they said and acknowledged. But you know, we cannot take charge of running their entire business and their IPR policy and all that. That's not possible.
I'd like to touch again on the buy me a coffee question.
Yeah, can you introduce yourself first?
Yes, please. For the third time now.
Yeah. It's good. It's always good to introduce again and again.
It's fine. My name is João, from the Wireless Intelligence Lab in Arizona State University. I'm still a PhD student. The question on the contribution, I mean, donations always have had some sort of negative connotation associated with the word, but sponsorship sounds better, and the GitHub does have sponsor. Well, you don't use GitHub, but in any case, the point is it possible to create a way for just users to contribute? Just have to have the option, because I do contribute to open source software, but Is there a way of doing that for OAI?
Yeah, absolutely. There is a
Is it
way.
just me that I don't know about that? Am I the only one?
Not really. You're not.
Well, how do you contribute? How do you contribute to OAI?
And see,
You go to the GitLab and then you create a merge request.
No, I'm talking about giving. Yeah, I happen to have a bit more money available than time. I do have. No. Look.
Okay, there is a structural way of doing it. There are different, for every project, I would say, even OAI, all the other projects which are out there, there's a structured way for most of them, let's say, or even not, that there is a way that you can be a member from being an associate member to different levels of membership, and then you can also be as a non-for-profit member, and then you can contribute financially, or also another way,
Yeah, but the woman was saying
the small contribution. So,
right.
Yeah. So the small contribution. So.
Just put on OpenAir.org contribution button. How many dollars?
That's it. That's it.
Yeah.
Look, 1,000 users giving $5, it starts to become something.
Yeah. Okay, that is
Slowly.
something.
Just start slowly, and companies certainly would put 100 or more. Start slowly. That's it. Yeah. Yeah, but the problem is sometimes you're too proud to just to put the hat on the floor, and it's not putting the hat. Like I am using OAI. I'd like to give something, just even without looking, monthly. I'd prefer giving something monthly. But anyways, maybe it's just me. But if you had a button, I would give.
That's a nice opinion, I would say. Thanks. Theodora? Theodora, can you pass the mic to Stefan?
No rush, no rush. Hi, I'm Stefan from FindTech, and we also use OAI on a daily basis. First of all, maybe a comment to the patent situation. It might be a controversial opinion, but I think all of us small companies, the economic realities is we can't afford having patent lawyers check all that. And I also understand the position of the alliance, but I think that could be something that the big partners who have the patents could contribute, at least having a list, okay, that and that and that of our patents is part of the code. So at least we can take the responsibility of knowing what we're using. So that's just an opinion. Question about all of us. What can we do as a community, businesses who use OAI, do to increase the stability and also, let's say, drive the roadmap a little bit more of OAI?
Anybody would like to take it? Yeah, it's a question for all of you.
Okay, first maybe in alignment meetings to actually be there and listen. That would be the first thing. There's a lot of silent partners within the calls. Sometimes it's just nothing coming through. That would be the first thing. And secondly, I think, like mentioned before as well, there has to be maybe some sort of a grouping around certain use cases or certain topics which are really valuable to a larger community. I think that would be the best approach. And then not just run after all the rabbits and all the whatever animal you want to put as an example, but rather focus on certain big things. And then if you have that, then there's an extra focus from those who are actually interested in that. I think that might help, I guess. But the first thing I mentioned, I think that would be the best thing. To actually be there when there are meetings, to be there when you have developed something and somebody's saying, that thing has a bug or it doesn't work like that. And then, okay, let's talk about it and let's fix it. There is this tendency, I'm sorry, I'm talking too much. There is this tendency of people who just, doing something and just launching it and dropping it actually, and that's it, all hands off, right? And then I think if you already benefited from whatever was given to you so far by the community and by OAI, then at least you have that, professional decency to, if you have done something and it has bugs, to fix it. But again, it comes back to,
That's a really good point which you made. It's all, I would say in one word, it's code ownership. If any company gives in code, anybody comes and gives in code, they should take the responsibility to take care of it further, because later the code becomes dead and it's a liability for the community to take care of that code, which is not use.
And
not
if you took the commitment, do it until the end. I mean, I think that would be one thing. I don't know if you guys want to add something.
Anybody would like to add, please?
I just wanted to add another question, maybe back to OAI Alliance. So what would be, from your perspective, our contribution to OAI? Like, how do you see, so we expressed our, point of view. So now if we reverse the questions back to you, how would you like us to help you or enrich the ecosystem? In what ways is the best interesting part for you? Is it financial? Is it engineers? Is it visibility, promoting? What is it? What is this?
Should I?
I can start just so. Hello, it's Robert from OpenAirInterface. So I would like to answer this. Huh? Yes, I am the RAN team lead at the OpenAirInterface Software Alliance and also the maintainer of the RAN repository. So I speak in particular from that perspective. It's simple, it's bug fixes.
Sorry?
Bug fixes. If you find problems, you should make small merge requests, only fixing one single bug at a time, not coming with a huge feature upfront, because, and that depends obviously on the context, what you're working on. So for example, since you and we were working on FlexRig, that maybe doesn't apply, but for like a small company that maybe finds some problem that starts to contribute actual bug fixes, that would be very helpful.
Exactly. Bug
and make it better for everybody, and that is not too much of a burden. Then for like financial things or like more strategic, I won't comment on this because I don't know. But from my personal opinion, being like really in the center is just fixing bugs. And maybe making suggestions for what can be improved, of course. Maybe sometimes companies, they don't know how they should fix something, or maybe it seems a bit too big. Then maybe also some input, some feedback of what can be improved and how in particular. And for example, also if there's already some kind of idea coming from the spec, how things should be implemented, that will often be helpful and should not go too far, of course. There's always like a line, but yeah.
Another thing I would like to say that the companies can also bring in on the table their feedbacks, as all you mentioned, because all of you have customers who are really using it out there, and they are doing a lot of test cases, which we don't do personally in our CI. So if you bring that feedback to us, which is also positive, sometimes it can be also, so it can be bad. So if you bring that, that also really helps us, it motivates us to improve.
I just like to comment that thanks to the maturity of the OAI code already has, and a lot of features that are already available, is becoming more and more difficult for new players to contributing. Because what is missing is very complex. You need to have very high skills at 5G to have new features contribution. So I'd say that bug fixes and testing could be a more simple way to
and documentation. Even you can just make a merge request to improve documentation. That makes a lot.
I'm just sharing the thoughts of Luis that shared with me. It is becoming much more difficult to come with new features because the simple stuff is already done and is working.
Okay. Anyone would like to add anything? With this, we'll wrap up our... sorry, please.
I want to say something.
Yeah.
I'm sorry. Just to go back to what we can do to make it easier to understand the patent issues. I just did a quick check here to see that I'm sure the information is public, and it is public. I don't think OAI should actually list anything like this. What we can do is at least say which standards documents we implement in OAI in a current thing, and then just point you to the Etsy webpage, which lists everything explicitly. Who owns the patents and which ones are for which documents, it's all there. I think that's their job to do that, and they're doing a good job. Companies should know where to look. It takes 2 minutes to find the information. Okay. The only thing that OAI is engaged in this, and this gets back to the panel yesterday, what we are going to do in 6G, is that anybody that's contributing their own patents in terms of an implementation has to declare that to us. That we asked in the contributor license agreement. It's explicitly asked that you declare patents. That hasn't happened yet. If any of the academic institutes are going to try it, maybe Eurocom will be the first one if we actually ever do get an SCP. That is something we're trying to do. We will test that. As long as my legal department says we can do it, we will do that. We can't ask, of course, any of the 3GPP companies to actually go and do that. I mean, that would really test the strength of the licensing that we put in place. I mean, that's up to their internal processes. But that's the only thing we actually did ask. So, and it has not yet happened. But otherwise, just go and find the information from Etsy, and we will put that somehow in our documentation.
Thank you so much, Raymond, for clarifying that point. And with this, I would like to wrap up the panel, and it's time for lunch. So thank you so much for a really interesting conversation, I'd say, right? And thank you for coming. Thank you.
Pants, actually my pockets holding me tight. Whispering a dream I could hold in the night. Look tight, a rhythm that's throbbing my vein. Wake up the